So this is week 8. Yeah.
Last week was 8, there was no terms out last week.
Week 8, we're in chapter 6, and we are reading schematics. This week's lab is about reading schematics. I'm trying to match the labs with the class so you can have kind of theory and also how does it function. Yesterday and the day before we did drawing of schematics, and we were able to draw schematics for an aquastat, which is a common component that we use in hot water heating system. If you have a hot water system, probably you have one of those in your basement. So we all got the chance to draw schematics. In the beginning, the first 5 minutes, we looked at that and we were like, okay, what's happening here? But after a few minutes, you realize that you know the components and you know how they function. How did you feel about that? You did that Monday, right?
Yeah.
But it wasn't that bad.
Not in the end.
Yeah. So within half an hour, you were able to understand what is this in your hand and what does it do, what are the functions, those sort of things. And hopefully that will give you an idea of how schematic is written and how do we interpret it. So we will try to interpret electrical schematics. What do they mean when they give us schematics? How do we read it? Electrical symbols. What is the symbol for connection? I'm going to write again. There are some common symbols, and sometimes some of them change, but so far from what I've seen, they're very common. If they have 2 wires, if there's a dot, that means a connection. What if the 2 wires are crossing each other with a bridge?
Jumping each other.
Yeah, no connection. Maybe they're overlapping, but they're not connected. You can put 2 wires over each other, no connection. Some of the symbols we see. What about this one here?
Transformer.
Good. What about this one here?
Single pole, double throw?
Other way around.
Double pole, single throw. What if one of them is closed? Double pole, double throw. That's a relay.
Okay.
And we saw also in the aquastat how do we connect the relay. These things are not just symbols for no reason, they actually go to certain connections. How to draw simple schematics. We did that in the lab. Trace electrical circuit. Why do we need to trace a circuit?
So you know where I can go.
What's happening? If it's broken, what's not functioning? It's kind of like when you go in your car, try to work. If the brake is not working, you can go check the paddle, you're gonna check the pads, you're gonna check how you trace the problems which you can troubleshoot. Also, it will help you know how to install small appliances like the primary control or aquastat. These 3 you will need to know how to connect very well, which is the primary control, which controls the oil burner. So this will go along very much with if you have gas or oil in your house, probably you have something similar to a gun burner. These can convert to gas or oil, and this will controls all the components, mechanical components in the oil burner. So this will go along with the oil burner. So how does it connect? And what is this control? Water temperature. It's kind of like a thermostat, but for water. That's why they call it aquastat. So wire diagrams, there are many types. The most one that we want to use is called installation diagram, which tells you simply how wire are connected, which goes where, and they try to make it very simple in terms of color coding, labeling, and also try to make it fault proof. However, mistakes do happen if you don't pay attention. And now in the lab environment, it's very easy because everything front of you. All the equipment are close. When you go to a house or an actual building, you'll see the equipment all over the place. Thermostat will be in the third floor, second floor, and the oil burner will be in the basement. And the power coming from probably far away. So you have to be able to trace those power and see where is it coming from. Installation, how do you get electrical equipment in the control panel? Also with troubleshooting. If it's not functioning, we want to troubleshoot. What components do we have? We have igniters, we have a pump, we have a motor, we have an inducer fan, we have a thermostat. So we want to know which one is faulty and why is it not working. Limitations, again, those symbols are different from one industry to another. If somebody is troubleshooting an electronic board, they have different kind of symbols and different kind of wiring diagrams. So for our intended and purposes, we only use the installation diagram or a ladder diagram. And over time, you will develop a sense of knowing how things connect. And probably within a couple of months working in the field, you don't even need the diagram. You already know where everything should go. Similarly to fixing a car, the mechanics have usually the repair manual, and after a while they just can go without it. When new equipment comes, it's very useful to go check the wiring diagram. Maybe there's been some kind of upgrade, maybe things have changed, maybe there's more control, more sensors. As an example of that, I showed you the evolution of primary control. This is the first primary control. It has only 3 wires. That's it. That means less controls and only one button. So this orange wire, everything goes to the orange wire. So everything turns on at the same time. Ignition, motor, and valve. Everything goes here, which is a wasteful. It's a wasteful way to connect all these components together. Why? Because we're gonna keep the ignition all the time. That's wasteful. You need that. And also it has less control. And the other 2 wires, where they go? Hot and neutral. So that was very, very simple. And we have only one reset button. If you look at this one here, has so many wires, hot, neutral, blue for ignition. There's something called interrupted ignition. So we ignite the fire, then we shut off the ignition, which makes sense. Otherwise, the ignition will be running the whole time, and you're actually overusing it. And the purple goes to the oil valve, which is another safety issue. We don't want the oil to be on all the time. We want it to be on with the equipment. And also we have something called the limit. The limit actually tells the control when it should turn on or off. Basically, if you have hot water, a limit, you'll put that in here. And also you have here your FF terminals, which you will learn what it means. It's basically a sensor for the light. So there are more controls here than the other ones. And this now is I think it's the 3rd generation, which has an LCD screen in it that tells you what's happening. And also you can measure the amount of flame and tells you what's happening. System is in reset, system is restarting, and so on. So different purposes. The ladder diagram looks like a ladder. It is like stuff the power and tap to the components. It does not look like the actual installation diagram. It just tells you the components and how they are connected. Gives you equipment operation during specific mood. I'll show you a few of those. Installation connections. Also sometimes it gives you troubleshooting and repair. Schematics have so much components in it. Tells you how, when, and why the system works, and when it doesn't. And it goes inside the components, so it doesn't show the relay as a box. It will show the relay with the small connection in it. It will go with this, all the little sub-circuits. We do not need to know all the sub-circuits. We only need to know for installation where the wire goes inside and outside the box. So for example, this is a ladder diagram, because things are connected in a ladder configuration. This is for an AC. If we look at it, we start from the power, L1 and L2. What is L1? L2 neutral. Can we reverse those? No, it's not going to function properly. We have, what is this? Transformer. So, if you have a transformer, what is the power going to be in this circuit? 24 we do for control. So again, what does that tell you? It tells you this is the power coming to the equipment, and this is the sub-circuit for the control. What does this look like? Huh?
Switch.
Thermostat. What kind of thermostat? Cooling, because it's an AC. Okay? So this circuit here is the control. So this is a thermostat, indoor fan relay, turn on or off the fan, and high and low pressure switches for the system refrigerant. These are safety measures because if we exceed the pressure inside the line, it should shut off the system, otherwise you might have a problem with the compressor. So, and this is a contactor. If you look here, we have C1 and C2, which are contactors that will turn on the compressor over here, and here is the relay contactor. So once we turn on the power, these are the two types of the contactor that will cut off both the hot and neutral, isolating the compressor. But once we turn it on, these should be closed, and the compressor should turn on when the relay turns on. What controls the relay?
Indoor fan relay?
Huh?
Indoor fan relay?
There's a relay here. It's controlled by the thermostat. And here we have a condenser fan motor for the outside, so the air will come out. Indoor fan motor. For any AC, there are two fans, one inside and one outside, and this is it's separated. It's not only one fan. In the window AC, is different. There's only one fan to the inside, not the outside. So there is not a lot of BTUs to it. High pressure and low pressure, and this is the run capacitor for the motor. So usually most compressors have their own run capacitors because they require a lot of torque and need something to kick it out to start. So looking at that now and seeing the legend, it's a little bit not that complicated. What do you think? Follow from the top to bottom. Look at the legend. You can tell it's an AC by knowing the components: thermostat, compressor, fan, and again, everything the first time looks a little bit overwhelming. Once you work on it 2 or 3 times, it seems very familiar. Like everything else in life. In the beginning, it's a little bit ambiguous, dark, but don't get overwhelmed. Look at it and try to decipher those symbols. And the reason that they put symbols instead of like putting the whole name is what? It's gonna get messy. It's gonna get overwhelming. And it's really hard to trace the lines. And if you look here, what are these dots? Connection between those 2 lines, so they are connected and then it's crossing. So this is the ladder diagram. Resembles a ladder, 2 vertical lines with the incoming power source. Is it always 110? No? Sometimes we have 240, 208, depending on the equipment. Use symbols to represent electrical components. It's always a combination circuit. Guys, phone's off. It's always a combination circuit between parallel and series. What is connected in series?
Switches.
Switches for safety and control. Look at these switches that are connected in series, right? And this control circuit is connected in series as well. In parallel are the components. Look at these components. These are loads, right?
Yeah.
They are connected in parallel, so each of them will get how many volts? Same one, 110 or 240. Compressor flow motor contacted power relay. Again, what is the voltage here? 240. What is one? One phase. We'll learn about that next week.
60 hertz.
What is 60? 60 hertz. We will learn how to decipher this line to know how much voltage should go into that AC. Again, these are in parallel or series? Parallel. What about these two? Parallel. So these all are all in parallel. Switch is in series. So in the book there are some basic schematics for most common equipment you will see in HVAC. There's not a lot, and again, once you know one of those equipment, they're going to be the same. A car is composed of the same things, no matter what model we make. Transmission, steering wheel, motor, the same components. It's just going to be a little bit different. But at the end, if you know one car, you will know all of them. If you know one window AC, they're going to be all the same. There are small, slight differences here and there, but they are all the same. Dehumidifier is very similar to an AC. And air conditioner, a window air conditioner, is very similar to the humidifier. Walk-in cooler and a freezer, fridge, they all have the same thing. And these, actually, the first four, they all operate on a refrigeration cycle, which means they have a compressor. If you are going to cool, you need a compressor. Gas furnace with a standing pilot. Gas furnace will have control, similar to oil burners, but we'll look at it. And also the packaged air conditioning unit. What do they mean by that? It's a split unit, either mini split, either mini split or central unit. But they are packaged well. What does it mean as packaged? It's sold as is.
Yeah, it comes solid.
They feel it's 3 tons, 3 tons, that's it. You put it the way it is, you don't have to change it. Lines fall off. So it's packaged, come with installation. What are the other options? There are companies who actually make you tailored ACs.
Like the way you want them.
Yeah, and how much tonnage you need it. I come with a usually you see them in big buildings. We have packaged units. They come and they measure the BTUs you need. They make a compressor and you do the lines. Sometimes even with packaged, if you have to alter something, they will have to come and do some measurement. Why? You're gonna have longer wires. You're gonna have longer lines. You'll need more refrigerant. Did you use the gauges yet?
What gauges? The
Refrigerant gauges?
revenues?
For ACs?
Yeah.
Okay.
We do it. It was like our first lab, I think.
Yeah.
Okay, good.
It was.
Good.
So we did stuff.
Excellent. Excellent. So this is a very, very important skill. Very important skill because again, not a lot of people know how to use that. And Bill is very good at it. Tell you how to refill. How do you know not to overfill the system? What happens if you overfill the system? What happens if it's underfilled? And what happens if you think it's underfilled and you fill it more? So it's very, very critical to know these skills. And again, don't be overwhelmed. Once you get a job, you'll be an apprentice, and you'll be at least for 3 months seeing how it's done.
Yeah, learning.
And repetition makes perfect. Remember how was it when you first started to drive? You still don't know where the signal is. You still know you're still very nervous. Then over time, it became second nature. Now you don't even think about it, right? Same when you go to your house. First time you put the signs. After a while, it becomes very automatic. So same thing here. You need to get familiar with it, and after a while, it becomes just second nature, and you don't have to think about it too much. You might change field at some point, so it will take a little bit of adjustment. When you go to a rental car, that is not your car, it takes you at least half an hour to be familiar with, with all the knobs, that's what's going on, and the gauges. So it's the same idea. So it will take a little bit of adjustment. This is a small, simple air conditioning system. Very, very simple schematics. If you notice, they don't put much in there. They're telling us the equipment, how is it connected. Simple as possible. Switches, this is an old model, 240 volts, and this is the switch on the board. One turn the fan motor, one has the compressor, and this has the thermostat. If you look at any window AC, there are always 2 knobs, right? One for the low and high temperature, that's the thermostat, and the other one is fan, cool, high cool. So it's gonna control the fan and the compressor. So this is a very simple air conditioning unit. And these are the switches. If you connect one of them, you only have fan only. If you connect 2 of them, it will be fan and compressor. And you cannot connect the compressor by itself. what would happen?
Don't know what happened.
No, it will turn on by itself, but there is no air circulating and it's going to accumulate frost. With frost and because the air is not moving.
Hey, are most air window units 240 volts?
In the past, not anymore.
Okay, I was gonna say it seems like it's really high.
But it used to be in the 80s, it used to be 240 volts. They need a lot of voltage to turn that on. Now they're 110. Yeah. Questions? Does this look complicated?
No.
No. If you get inside into it, it might be a little complicated. You'll find connection here for the capacitor, fuses, what have you. But this is a simple ladder diagram for a window AC. Let's look at this. Walk-in cooler, same idea. Evaporator, fan motor, timer, defrost timer, compressor, and condenser fan motor, and these are controls which are in series or parallel. Series, and these are all in parallel. And why do we have a defrost? Because we will have some kind of frost going on. Most freezers have a defroster, which since there is a sensor. If you have accumulation of ice, it will stop the compressor, and sometimes it turns on a heater. We'll just try to cool it off. Most ACs in the 80s, they usually have that. You wake up early morning and the AC stops working. It's humming, but there's no air coming out of it. And you look at the evaporator, and there's a lot of ice in it. So now they stop that problem by reducing the amount of humidity, and also by having a sensor that will turn off before it accumulates a lot of frost. Commercial freezer, same idea. So it looks very simple to look at in the paper, but when you go and try to locate this equipment, it's all be a little bit challenging. So the first thing you would do, when you look at the schematic, try to match the schematic with what's happening. Remember when I told you, when you try to find your place in the map, what are you gonna do? First of all, you find,
Look at the legend.
look at the legend,
And look where you are.
look where you are, find landmark. If I'm in Springfield and I'm trying to find myself, I'm gonna look for, in the map, I'm looking for landmark. MGM is here, Main Street is here, State Street is here, so you can find your location before you can navigate. So this is what you will do when you look at schematics and you also look at equipment. Look at the schematics and try to locate those components. This is the first part. It takes a little bit of time, but it is doable. Two more components. This one is gas furnace with a standing pilot. What's a standing pilot? So a lot of gas furnaces have a flame going on forever, but it's not the code anymore. Remember those old stoves with a small pilot near the burner? So you just turn on and it goes on. That's not the code anymore. They stopped making those. It's very dangerous. You open the kitchen window and air blows and the pilot goes out and you can smell gas. So it's not very safe. But you'll see that in some furnaces there's a flame going on the whole time to make it easier for you to light the gas. It's the packaged air conditioning unit, which means either mini split or central air. What do you think?
A little confusing right now, but
Once you look at it, give it some time, it should be
I think
easy.
it's easier to see it
Yes.
mapped out like this
Yes.
than any other one.
This is easy to see the components so you can go and locate.
These are ladder diagrams?
Huh?
Are these
Yeah.
installation ones?
These
too?
are ladder diagrams.
Oh, ladder.
And installation is when they give you the outlet, what's the next to what. Okay, I'll stop here.